Hello, everyone. Welcome to the last episode of the Day Zero podcast before our summer break. I'm Spectre. With me is Z. Happy Victoria Day for our Canadian friends out there. I don't know how many we have, but I'm sure we have a few. In this episode, we have some impactful misconfiguration bugs when it comes to mobile, a Windows bug in the HTTP kernel driver, and some other research sprinkled in. Before we get into topics, though, once again, we are going on break for the summer. This is our last episode until September 6th. So I believe that's the first Monday of September that we're going to be back. We're not going to be stopping content completely, just taking a break on the podcast. We will have some other streams. For example, last week, Z and I did a stream looking at IDA Free, which has the cloud decompiler now. So for the first time ever, Hexphrase has a free decompiler out there. It was pretty cool to check out. We didn't really cover that on the podcast when IDA Free dropped, but if you want our thoughts on that, like I said, Z and I did a stream on it, looked into it. A VOD will be going out for that this week, so keep a lookout for that. We always put out any videos and whatever in Discord and on Twitter. So if you follow us on those mediums, you'll see immediately when those videos go out. Also, we have our mini-series out now for making the transition from CTF to real world. It consists of 3 videos and 3 blog posts, and with those, if you prefer blog posts to videos. The first discussion talks about an overview of the differences and challenges moving into real world from CTF. The second video tunnels in on vuln research and some strategies for learning that. And then the final video is on exploit development in a similar fashion. Strategies for learning it and how to make the shift and the differences between CTF and real world.
Yeah, I mean, I am kind of excited to finally get it out. I've talked about wanting to do this post for quite a while. So to actually have it out is kind of nice. Covers a lot of topics that I think just haven't really been hit on too much.
Yeah, it's a cool discussion. I think especially the exploit dev discussion was probably the one I enjoyed the most. Because the first one's kind of ramping up into the other two.
Yeah, and the vuln research one is more just like, I feel like it's necessary for that in order to get into the exploit dev, rather than treating exploit dev as like entirely separate.
Yeah, you got to kind of lay the groundwork a little bit. So yeah, we cover all of that in those videos. So yeah, just wanted to shout those out quickly. With that out of the way, we can move into a little bit of news. So GitHub put out some updates on their exploit and malware policy. You may remember we talked about this a few weeks ago, and there were a lot of concerns around unclear use of terms and the way they phrased their statements in the policy. So they finally made an update based on that feedback, and at least with some of the stuff that I've looked at, it looks like they've done a better job here. If you may remember the last time we covered this, the worrying phrase that we talked about the most was the we do not allow content that contains or installs exploits or something along those lines.
Well, so there's concern around the word, like anything that harms, like a lot of vagueness just around what exactly harm meant.
Yeah, just kind of leaving things unexplained and leaving it up in the air. So they've now reworded some of those phrases into now like directly supports unlawful activities or malware campaigns, for example, just adding a bit of clarification on what they're talking about. And they also added some examples around what they mean by technical harm, such as causing denial of service, physical damage, overconsumption of resources with no clear purpose other than abuse. So like not doing a security assessment, right? If you're causing a denial of service and there's no clear other intent, then that is classified as not allowed. So
yeah, and they do call out like educational content, obviously dual use content or something. They start calling out specifically, which is definitely, it's indicating that they're listening to some of the feedback that was there. I mean, they did put out the last policy for feedback. They got that feedback, which was largely negative at first. And they've clarified that. I mean, it's, the right move on their part. I think like they do need to have a policy that includes the ability to take some things down, especially with GitHub kind of offering like a CDN sort of service. And they do actually mention also a little bit about what their takedowns would look like. And in a lot of cases, they mention that their takedowns are only, we put it behind like normal authentication. So you can't just provide it as an anonymous file, but need to log in to view the pages, which I think is extremely fair when it comes to some of that content, because that does stop kind of the malware attacks that are just kind of grabbing the file and won't want to like log in as a particular user. So I thought it was interesting that they added that information also, and I think it's completely fair.
Yeah, I like these policy updates. I think I said at the time when the initial call for feedback went out there that a lot of people were being uncharitable towards GitHub, saying that this is just another thing that Microsoft's trying to do now that they own GitHub. They're trying to remove all exploits or whatever. And I feel like people really jumped the gun there. And like you said, it was a call for feedback. It's not like they just threw it in there. And I feel like these updates reflect that, right? It reflects that they're trying to act in good faith. They're not trying to, completely tank the security research community on GitHub. I think their statements here, especially the way they've reworded them, are pretty reasonable and resolved a lot of the concerns that I saw raised on the initial call for feedback. So yeah, I think they did a good job here. I think they took the feedback in stride, and I didn't like, nothing really stood out to me as being bad. I don't know if you have anything to call out, but I think overall it was a positive set of changes.
Yeah, no, nothing really stands out as being a poor choice to me. Ultimately, like I said, they do need to have some sort of content policy. They have made this fairly clear. They have tried to define what they mean by harm, or if replays now with technical harm, and including examples of what they mean. Making it clear that they're not targeting the educational content. They're not targeting dual use content. Basically, they've made clear on everything, on every objection I think I've really heard, that, or every meaningful objection I think I've heard.
That's a good way of phrasing it. There have been some unreasonable takes out there. So, yeah, like all the reasonable stuff I think was addressed there. So, good job on GitHub, I guess. All right, let's get into some exploits. Up first, we have a checkpoint research topic about various application developers who have misconfigured or badly implemented integration with cloud services, which all in all could have exposed over 100 million records of personal data. Z, I'll let you take this one away.
Yeah, definitely the potential for a lot of records to be out there, and they don't... They kind of talk about a lot of this in vague terms. They talk about the general issue, not really going into every specific application. They have a list, I think it was towards the end here, of every application, the rough vulnerability they had. I more want to use this as a point to touch on, well, the three issues that they do talk about are misconfigured real-time databases, having your cloud storage gain misconfigured, either with the keys in the application, something like that, and the keys for push notifications being in the application. I want more use as a point to touch off on just cloud security in general, because this is very common when you start running into any sort of mobile apps, or even a lot of just in the cloud applications, so things built like over Firebase from Google. You run into a lot of those cases where it's so easy to not configure security appropriately. And I kind of put the blame a little bit on Google and AWS and Azure and the other providers on providing easy to configure insecurely products. I guess I poorly phrased, but the example here on the real-time database is really easy to kind of configure something like, I want to say Firebase, but I think Firebase is the name of their larger application. There's a couple, like Firestore or something, I think is the actual name of their storage and real-time database, but it's really easy to kind of set that up. And when you set up something like that, you're kind of leaving yourself in a position where you're not setting up like a backend server anymore. You don't have your traditional, here's my front-end application, here's my backend server where I'm running like the database, and I'll write an API in front of the database for my application. Instead, you're communicating directly with the database from the application. And Google, of course, understands, like, there's security implications of that sort of two-tier architecture. So Google is kind of providing the API to the database and the authentication there, but you need to know how to configure that properly. And that's where, I mean, a lot of people just don't realize that security implication of one, every user kind of has all the access, and this is the same endpoint developers would be using. So it's just really easy to kind of misconfigure. Kind of same deal when it comes to cloud storage. In that case, it's more about the keys, where when you stop having the backend server, now where do you put the secrets that you need? You should still have something for that. So clients don't get it. That's kind of the deal with the push notifications, is you want to keep that secret key away from the client, but it's so easy to just build your application. You're already doing all of like the database logic in the application. Why not include these keys in there also? That's effectively what they found. It's not earth-shattering or anything too crazy. It's just some very common vulnerabilities. They did in particular find that one developer here had the keys using base64 encoding, but that's not really much security, and I can't even say if the developers thought it was security or not.
Very strong obfuscation. Nobody will be able to decode base64.
Yeah, I mean, the thing is, the value is needed by the client. Well, in their architecture, the value is needed by the client. The architecture just shouldn't be so simple. Like, they should have a backend server where secrets things can be performed, or only using APIs that are kind of safe to use from the client, which push notifications are not.
You could kind of skate around this issue by using Android Secure Storage, no? Or am I was just kind of thinking about it when you were talking about it.
To an extent, you can.
Yeah, like, I don't think it's the best solution, but it's probably better than base64 encoding it.
Yeah, base64, isn't anything, but the developer may not have even thought it was.
Yeah,
either way,
you gotta kind of assume their intents there, I guess, a little bit.
Tons of records being exposed there. They do only really go off the Google Play installs to get their number. A lot of them having 10 million plus installs, therefore, however many records.
Yeah, it was quite a few records. The one that I found funny was the Austro Guru one. Not even really anything super like technical or anything, but the information that they had stored, they had like the email, name, gender, birth date, which is sensitive, like personal information. But the birth date they had down to the minute. They had the minute of the birth date and the personal information. I guess that's important for astrology. I don't know.
Yeah, I mean,
familiar with that area, but
that's what the alignment of the planets at the time of your birth.
Oh, right. Okay, I see.
So it kind of makes sense that they have it. But
I just thought that was a really funny field in there. But yeah, I think this is a good post. Like you said, it doesn't really tunnel in on a specific target, just kind of more of like an overview and kind of like a researchy type post, calling out what application developers commonly misuse. So, all right, up next we have QNAP, QNAP MusicStation, and MalwareRemover, which has some issues. We'll say MusicStation had a pre-auth arbitrary file upload, and MalwareRemover had another arbitrary file write that was even more powerful. Firstly, we'll talk about MusicStation, which isn't a pre-installed application, but it is a popular app. One of the things that it allows you to do is upload album covers onto the NAS. Since it's a MusicStation, that's a functionality that makes sense to support. The problem is they take both an art type and a file name with a verified image extension, and they combine that to create the file path to write the image to for the cover. But it's not protected against path traversal like at all. So by just setting an art type that's like // whatever, you can traverse directories to get an arbitrary file write as root to a somewhat controlled location. It is limited by the fact that you don't control the full file name, because the code does some like manipulation on the file name. Like, it'll add some a unique string, I think, towards the end of it. So, and you are limited by the extension as well. It's going to keep that extension in there. So you do get the arbitrary file write as root, but the impact is kind of limited there. You're not really going to be able to overwrite files very easily. Just plant new ones on there. The second issue in MalwareRemover is more impactful though. And unlike the last one, it's a pre-installed app, and ironically, it also can't be removed. So if this app is installed, you're kind of vulnerable by default because.
And I kind of like when anti-malware ends up being the issue, or antivirus.
Yeah, it's a fun class of products to hit. So the issue is when it runs its malware scans through a cron job, which it'll do at a certain time every day, which you can configure. It'll run a script to do that scan, and that script will source a common script, which traverses a directory in the package called modules to load in Python modules and whatnot. And one of the modules it loads is the auto upgrade module, and that module has an arbitrary file write issue where it mounts a temporary file system on temp config. And if that file system contains a tarball, it'll extract that to a temporary folder. Well, when it does that extraction, there's no checks against path traversal, and there's a race on the config mount because somebody can just write into that directory while the script is operating on it, because they do try to do some checks on the file system they mount, but I mean, they can just, somebody else can race that and do it after the checks, but before the tarball is unloaded. So, and temp is accessible to everyone. So, because of that, you can abuse that and use something like EvilArt to plant files on the system. Again, you get that file write as a root, and where it's not as restricted as the first one, it's fairly easy to get a reverse shell as root and then pop the NAS the next time the MalwareRemover does a scan. So, yeah, I mean, the second issue is obviously a lot more impactful than the first one, but the issues themselves are not really too earth-shattering. It's literally just a tale as old as time. We don't check the paths, especially in tarball, like tar extraction. That's just an area that is not protected against very well.
We've talked about these sorts of issues quite a few times, I think, in the past year. Over the podcast in general, really.
Yeah, if we had to do a count, I don't even know how high it would be, but it would be high. It would maybe like 50 or something. It's a lot. So, yeah. Up next, we have a quick two-factor authentication bypass through forced browsing. The affected product was kept obscure. They didn't want to talk about it because they found it in a private bounty program. The post first touches on forced browsing, which is kind of a fancy way of saying broken or non-existent access controls. Usually with this target, you need to provide a one-time code that gets sent to the email address when you register to validate that address. It's unclear if this also includes needing that to be an internal domain email, or if this is just bypassing the need to verify emails in general. They don't really talk about that too much, I guess, because it was a private research.
Because it's a 2FA bypass, I'm assuming it's, and because they only talk about here, I mean, I'm assuming this is just like they bypass it at like just the one time. Like it's not really a continued thing. And I mean, having an email token, there are a few websites that'll do that where it's like a magic login link. In general, though, I think it's usually you just kind of verify it once. They bypass the need to verify that one time.
Yeah. The details are a little bit lacking here, which I do kind of understand, where they wanted to not give away too much information to keep the product, not noticeable to whoever's reading it. But anyway, when they do that one-time code check, it's all enforced on the front end. But the problem is you can intercept the post request, which usually goes to the API sign up verify endpoint. You can change that to go to API sign up and just remove the verify off the end, and then add the password into the request body where it usually isn't there. And then whatever happens on the back end when it goes to parse that, it just accepts the ability to create the account without needing to send that one-time code. So it's just bypassing the one-time code requirement for registering an account. So I'm not sure how high the impact really is there. Like I said,
well, if you're able to register an account as any email, I mean, I would be interesting. So you're kind of getting it earlier. Like, if this include like forgot password or something. I'm assuming not, because then they probably won't mention that. But the ability just in general to sign up with any email. I was a bit disappointed on this one because it does mention it as a second factor authentication bypass. Whereas email authentication, like unless it's being used during the login, like I mentioned, that sort of magic link, I wouldn't consider it a second factor authentication. Like this one doesn't really come off as second factor authentication to me. I can understand why they call it. Like, I don't want to be all nitpicky on what they're calling their posts. I just had a different idea when I saw the title of this. The one thing that does make me kind of raise a question here, though, is they do mention specifically that you remove the /verify from the post request. In the body of that post request, add password, any password. So presumably you can actually put in any password, and it's not actually specific to that password. It's just interesting that in particular was needed, especially since they mentioned that you do fill out the password as part of that initial post. Like when you're making that post request, you do need to fill out the password. So the fact that it's not there is like when it's going over to verify, it's just a little bit weird to me. At first, when I was reading this, my thought was maybe this was something like it would just kind of iterate over the keys provided and set those fields within the database for the user. That seems kind of like it's a mass assignment type of issue, but it's not unheard of to do that. So it seemed like, okay, so you just provide the password when they're not expecting it. But now I just kind of noticed that my understanding there is mistaken, because you do send the password initially, unless it just doesn't actually use it at all. But yeah, because my feeling here was that this was actually more towards a mass assignment sort of issue, but within the database. So mass assignment of database columns. So you prematurely issue the password and set it to something, so you're able to log in and bypass the actual verification. That might not be the case. I will say I don't think there's any way we're going to know what it was. Like, it's just the information just isn't there in this write-up.
Yeah, we're kind of in our favorite place to be, which is speculation land. Yeah, the main place where my mind went was like where websites will kind of whitelist emails you can use to sign up, and that's where I was thinking this might be useful for bypassing that verification of the email. But
their example email is at gmails.com.
Oh, okay, that's true.
So is gmails.com actually like the same as Gmail?
I have no idea. I don't know. Maybe they have like maybe Google has registered that one too.
I probably should have just yeah, no, I haven't seen it either. It doesn't look like it's loading, so my assumption is that might either be a typo or they were just hiding it in general, like not showing their actual email. Fair enough. I just noticed that.
Typo is probably my guess, but yeah, hard to comment too much on what the impact exactly is, where we're so limited on the target information.
Yeah, I mean, being able to bypass the verification is worthwhile. An interesting attack with that, I mean, could they sign up for an email that's already registered?
Ooh, that is an interesting question.
That would be one way you could take this, that they don't indicate. Like, we don't have that information. But that would kind of be one attack that would at least be interesting to try, especially since it does seem like there is a little bit of trust in the client going on here, where it might kind of like you skip some of the checks, such as this verify. So there's a chance that that sort of check might be skipped also. There's also a chance that it wouldn't be.
That's a cool attack to call out. I like that one.
Yeah, but I mean, we don't know, and honestly, there just isn't enough detail in this post to go beyond that, but I thought it was a potentially interesting post, at least to cover.
Yeah, I agree. All right, we'll move into a post from Dullien about GraphQL and CSRFs. Again, this is one of those posts where it's not really touching on a specific issue, more just talking about the class of CSRFs as a whole, and where they can appear, even though the developer might not expect it when using GraphQL. So they go through a few examples there. One example they give is with post requests. They may think that because like application JSON content types are believed to be invulnerable to CSRF, since you typically can't send those request types from a CSRF context.
Yeah, so I would actually touch on that. Like, if you're in an environment where Flash is available, you don't need to exploit Flash for this, but I used to have so much fun doing kind of complex CSRF because Flash would like you set certain headers, like you wouldn't be able to send an HTTP request, but you could just, inject your attack page would include a little SWF file that would let you make other HTTP requests, and they would be made in the context of the browser still, like with all the cookies and everything. But you can go ahead and add whatever headers you want. They ended up restricting Flash. They've restricted the headers you could add a couple times. So I'm not sure if like current Flash would even let you do application JSON. That is kind of a rough target. I mean, it's not like Flash is widely deployed anymore. But that was one way you could deal with the application JSON issue that I guess kind of forgotten about, wasn't well known even at the time.
Flash really was a hacker's best friend, huh?
It was.
Yeah. So so application developers may think they're kind of invulnerable to CSRF with those request types, but they can be fooled because the middleware will sometimes accept form URL encoded requests in place of them, which those requests can be sent from a CSRF context. So that kind of opens the door to the CSRF type issues. Another set of issues they mention is get-based CSRF due to using GET requests both in terms of queries and mutations. I think
which you just shouldn't do, but people definitely will do it. In terms of the middleware, something else that middleware will provide that isn't mentioned here is occasionally you'll be able to change the method of the request. And there will be, and this just depends on the middleware, so you have to kind of do the research, do the legwork on that yourself, but where you can include something like a URL parameter underscore method and change it from get, or we'll put post in there, even though you're sending it as a get, and it'll rewrite it for you. And I have seen that also for indicating that it's a JSON type request versus the standard one. So you can send a standard thing even though it's not actually. Usually this kind of meant more for like during development periods, but I have seen it hit production. It is just something worth looking into. I think we've covered it before. I forgot to look up what episode. It was quite a while back that we will have covered an attack using that though.
I was about to say, I can't recall specifics, but I know we've covered that exact type of issue before with like the request being rewritten. So, but like you said, it's been a while, so my memory's not good enough to remember when that even was exactly, so I'd have to go searching. But yeah, like the one thing they mentioned there is like a way they suggested the GET request being abused could happen is if an application is misconfigured and exposes the GraphQL console, which allows both query and mutation requests. And then another issue they call out is when state changing operations like setting user data is exposed on GET queries. And the example they give there is one where like it sets a user email and takes an ID value, which an attacker can control in the query. Toward the end, they talk about how these types of issues can be abused to perform things like cross-site searching to exfil secrets. It's a perfect medium for that kind of attack.
Cross-site search actually, especially when you're doing like the timing attack on that. If you're able to get something to hit to GraphQL, that is a really good way to use it. Obviously, because GraphQL, you're using it to query. It's a very powerful query language. You can get a lot of information that way and figure out a lot by creating the right timing query.
Yeah. They also released an extension that's worth calling out. They released an extension called InQL, which is a burp extension to automatically test for the issues they detail here. But yeah, like I said, it's more just talking about the things that can happen, not things specific to a target, just things to be aware of, I guess, if you're a developer. They did also include some stats from research they've done on various top companies. I don't think they don't really go into like specifics on what those companies are, but
Which
they said
is understandable.
Yeah, completely. But they found that 50% of them were vulnerable to cross-site searching, and 10% of them were vulnerable to more powerful CSRF attacks. So yeah, that was kind of a nice little gem they had at the end there. But overall, just a good post. And we've talked about GraphQL before in some topics, but I don't think any of them really covered as much breadth as this article has.
Yeah, that's the thing. This one doesn't get too much depth, but it does have good breadth on it in terms of just covering a good number of attacks. But yeah, we have covered GraphQL before. I don't think we've mentioned InQL before, but it is quite useful. I should have had some other tools kind of ready to recommend also, but I mean, this does also just come down to protecting against CSRF, though, which is a reasonably well understood attack. Especially now you're starting to get same site cookies. If you start using that, that'll make some of these attacks more difficult, although GraphQL is often meant to be, I guess I say often, not exactly. At times, it is meant to be consumed by a lot of different domains. So there is still kind of the room for such attacks, though I guess when it's supposed to be consumed, it probably shouldn't be doing any mutations.
But yeah, it's one of those posts where it's talking about a common bug class. Like you said, CSRF is pretty well known, just in an area that people haven't really thought about too much yet and haven't really been hammered yet. So,
well, I mean, it's not that people haven't really thought about it, because we've talked about attacks that have gone on to abuse GraphQL and acts like this, in whatever way they could. So it's not like it's not there, but like you said, there's a breadth to this post that's worth discussing and worth pointing out.
Yeah, I think the most recent one we've covered was some of the Facebook issues and how GraphQL was abused there.
Yeah.
So,
although that was more of they had XSS, so they could, or like they had.
I think it was XSS, yeah.
Yeah, or they had the token actually, and then they were to use that to steal the CSRF token and then make further requests, because the CSRF token was in GraphQL.
Yeah, so you can check out some of those previous topics if you want more specifics on GraphQL, but this is a good a good primer, overview. I think. Yeah. All right. Next, we have an RCE in Squirrelly, which is a JS templating engine. This is coming out of GitHub Security Lab. The issue that they're covering comes down to two things. First of which is taking configuration data through the Express Render API, which they state, again, is one of those things that you shouldn't do, but a lot of people do because they're lazy or just don't want to do it the proper way. Because the templating engine does need to be able to receive configuration information on things like where the template is located. And if the developer is lazy, like in this case, they can just take the configuration parameters through the Express Render API. On its own, that isn't going to lead to a compromise, but it does open the door for a vulnerability to get a really powerful attack vector. So it's kind of a second stage issue. The issue that makes this actually exploitable is the templating engine allows untrusted users to pass objects into the render engine, and it will accept config options through that interface. So if that happens, an attacker could just write a query that can overwrite an internal config option and you abuse something like a filter that will run JavaScript, and you can just change that to get code execution.
Yeah, so their example case here is turning off auto escape, so then they can set the filter such that it actually performs code execution. That was their example attack. I mean, it really does come down to just that mixing of code and data. Or in this case, the configuration data, but like it's that mixing of data that shouldn't mix, I guess would be a better way to put it. Like you should have your configuration set up separately from providing user data.
So the key issue there is just that, problem of allowing untrusted users to pass in the objects. The second stage, this is kind of an interesting question. Would you consider the fact that an application takes configuration data through the Express Render API a problem on its own, or would you not, since it can't be abused without another issue to chain with? It's kind of a I could see you kind of going either way on that. But I would personally, I would think that would also be like an issue worth calling out, like its own kind of CVE, I guess.
Well, I
But
don't know if I'd call it a CVE. Just because, like I said, it's not a security issue on its own. It depends on the actual application developers making the insecure choice of allowing user data to come in as that configuration data. Like, this could easily be solved by, in their templates, using like a separate data field where they would end up passing this in. So then it wouldn't be treated as part of the I guess upper map of that dictionary that could contain configuration. So there are ways like the developer could use it. It's a poor design choice for sure. I don't know if I would necessarily expect a CVE to be filed over this vulnerability though, versus just reporting it as a high level potential misuse location. Because like you said, it requires somebody downstream write bad code. It doesn't stand on its own as an issue. You need to have it used poorly. And using code poorly, I think we've talked about this before when it came to a crypto library. I forget what it was. Where it just comes down to like, yeah, there's bad code and bad usage of those libraries. And those libraries, I think, should be held to a certain standard of like ease of use. This was especially so when it came to the crypto issue that we were talking about. In this case, they are following a fairly common pattern. Like, a lot of templating engines will work this way, or will work in a similar way. They could do it better, but yeah, I wouldn't necessarily call this on its own a CV without something internal being exploitable, I guess.
yeah, I think I would call it more of like a red flag or a code smell. I just wanted to bring up the question because it is the kind of thing where I have seen some debate before about like whether or not it should be considered, maybe not a CVE specifically, but like whether or not a company will take that as an issue and actually like address it or whatever.
So if you're talking,
CVE is just like the shortest way to say that.
I guess the other way to kind of think about this, so it's like, what about a bug bounty? Would you report this in a bug bounty? That, I think, is a more interesting question. I would want to lean towards no. I could understand why somebody, though, might just, want to toss it out there. It's like, well, maybe I can get some money for this if they, accept it.
So the argument that's kind of forming in my mind, if I wanted to play devil's advocate, is like, if you wouldn't accept this issue in a bug bounty, then would you accept like an authenticated XSS or something in a web app? You need a first stage attack to be able to get in, right? It's behind authentication, so you need an authentication bypass or something, but it's still an issue. So I guess, obviously, on specific bug bounties, it's going to depend on scope, but
no. So I think your XSS comparison kind of falls apart because it's an issue elsewhere. With the cross-site scripting, like, I think you should still accept cross-site scripting regardless of whether or not it's authenticated, whereas I can kind of be against this one. In the case of cross-site scripting, your code, like, you're the application maintainer, and it's your code that is still vulnerable to cross-site scripting. In this case, you're the library maintainer, you've built this library, and it's somebody else's code that is using it insecurely. Who's calling, a function they shouldn't, who's using it in a way that they shouldn't be using it. It's somebody else's problem. It's not the library maintainer's problem. Whereas cross-site scripting, in that case, it's all inside of the one application.
That's a very fair distinction. So yeah, fair enough. I'll throw away my little devil's advocate argument then.
Yeah, so I mean, I could understand, like, if somebody were to say they'd report it, like, I feel like it is one of those very low rating issues, like low severity issues on its own. It is one of those things that feels like it's just like hoping you're going to get a payout, hoping you're going to get a little money out of it, and that's all. I wouldn't really blame somebody for it. I disagree with it. This is something that you could report on a vulnerability assessment, application level pen test. something like that, reporting it because you're trying to let the client know, like, hey, here's what you need to be aware of. Here's kind of the thoughts. Here's how you can mitigate it. Do with that as you will. And you're just providing the client all the information. Bug bounties, I think, do need to be a little bit more selective on.
Yeah, in terms of bug bounties specifically, you're going to have to squeeze it into the scope, basically. If they consider this type of issue out of scope, which they most likely will, then I guess you could submit it if you wanted to, but don't be surprised if it just gets closed as invalid or whatever. So,
yeah, I mean, because this is the same. If you were to imagine a library providing like the ability to call eval, kind of the same idea. Like, it's not a good idea, but without somebody actually calling it, there's no vulnerability.
Yeah, you have to demonstrate it can be taken advantage of in some kind of way from an attacker's perspective. So
I do think it's fair for GitHub Security Lab to call this one out. I do think it would have been interesting had they called this out, like just called this out as a class of attack on like multiple different template engines, or at least kind of cover that they did look at other template engines. It's like they're kind of calling this one out that I haven't heard of. That's squirrely.
Yeah, I hadn't heard of it either.
Maybe
before.
It's the only one doing it. I don't know.
The way they phrased it made it sound like it's not. Like it sounds like it's a pretty common thing. So
yeah, so I would expect more reports either to come out from this that are very similar or something. I guess, they did have their deadline and just disclosed it after the deadline, so maybe we'll see more in the near future.
Yeah, I mean, we've seen GitHub do posts before about like things they report on often. I'm trying to remember the specific title that I have in mind. Yeah, I can't think of it right now. But they have done some of those like researchy type posts before where they call out a class of issues.
Oh yeah, I really liked their look at the glue, where they were looking at attack. I want to say they called it attacking the glue, but they might not have. Where they looked at attacking the middle layer between like Python and C, where you have that interoperability layer, and looking at finding memory corruptions and stuff in those calls. I thought that was a really interesting step from them, and I think if they did something that was kind of in the templating engine, or did a post like that in the templating engine, that could have some really interesting content. I mean, GitHub Security Lab does some solid research. Etienne mentions out of, I found a bug in Math.js once and thought it wasn't really a bug because it was basically an eval function. Then months later, someone also found it and made it into a huge deal. That's the thing. This is the type of issue that you can get people behind you on this sort of issue pretty easily. I think remaining professional, it would still kind of be, if you're hired by them to be doing this assessment, give them all the information, just be like, be real about it. It's not an issue on its own, but, be real about it. If it's on a bug bounty, though, and outside that, I have a hard time recommending you actually call it out. So I guess one thing you might want to consider is documentation around the dangers of the function. Like, I guess maybe not reporting as a bug bounty, just reporting it as like, hey, I noticed you guys do this. You should really document like the dangers of it or something like that. But it is the type of issue, especially in eval, compared with this, which is just the configuration aspect, although it can turn into RC, so you can relate to the eval. Eval being a little bit more direct. My feeling is like you could very easily, get on Twitter and rile up people around it.
Start the Twitter mob, get the pitchforks. Yeah, we've definitely seen it before.
Bug fix by mob.
Yeah, that should be an actual label. And also they called out also templating engines are so bad. Yeah, it doesn't surprise me. I don't really look at templating engines, and I haven't really seen much around them. I don't know if it's just because they don't really get as much publicity, but doesn't really surprise me, especially with like how complex they have to be sometimes with the features they want to provide. So yeah, we'll move on to our next topic, though, which is 2 NoSQL injections in Rocket.Chat, which was detailed by Sonar Source. The way they interact with each other is quite interesting. They state up front that each on its own could be used to hijack an admin account, though that is a little bit shaky on the first issue. But combining them can make for a more stealthy attack. So we've covered Rocket.Chat quite a bit before on the podcast. In the beginning of the post, they talk about some background, mostly the fact that Rocket.Chat uses MongoDB for user data, which I think we've talked about before too. Some issues around that.
I mean, there's nothing necessarily wrong with using MongoDB.
No, I just wanted to call out that we talked about Rocket.Chat background a little bit before.
Yeah, and Rocket.Chat, like, they're really good on HackerOne. Like, they disclose a lot of their reports, and there is a report for this one also on HackerOne. They're really good, so that's why we end up kind of covering them, because they do disclose their vulnerabilities and are very open about it.
Yeah.
But I will add, like, with MongoDB, it just comes down to the fact that developers aren't necessarily thinking about the complex queries that you can do with MongoDB. That's where the vulnerabilities come in here, like your ability to provide an object in the place of just a standard string query.
Yep. So the first vulnerability is a blind NoSQL injection in the get password policy method, which can be called on a user without being authenticated, but they do need to know the email for the account to access, and that user can't have two-factor authentication enabled. The problem there is when they take the token from the user-provided parameters to that method, just like Z said, they just take the parameter and pass it straight in. They don't make sure it's just a string. It could be an object. So what they abuse here is providing a regular expression or a regex expression, which allows you to effectively create an oracle for your brute force token using that oracle. Now, abusing this issue to take over an account doesn't immediately give you elevated account privileges. You could target an admin account with it, but it does create a lot of noise. A reset token is going to get sent to the user, and they're going to get logged out, and they'll know something is wrong because their password has been reset, so they're not going to be able to log in anymore. So because of the fact that it's so noisy against the user, and the fact that admins should have 2FA enabled, using this on its own to hijack an
but I'm sure there are a lot of admins who don't go and actually enable 2FA.
Again, should in quotations. But yeah, like those two factors kind of make it not ideal to use that attack to immediately go after an admin account. So that's kind of where the second issue comes into play, which is in the user list API. This is behind authentication. The user list API will take a query parameter for whatever field you want from the user. They do attempt to apply some blacklisting on the fields you can request for obvious reasons. They don't want you to be able to get like account tokens or passwords. But again, you can inject objects in there. And you can use the where object in Mongo to run JavaScript on fields. The JavaScript is really restricted. They worried that it might just be a blind injection like the last one was, but they did find a way to get output through throwing errors inside of that expression. So that can allow them to leak the field contents of any field. So they could leak the 2FA secret, the password hash, the email, and just about anything else attached to the user. And that allows them to hijack admin accounts in a reliable way because they can use the integrations or webhooks feature to write some JavaScript and get RCE. And then if they abuse the first attack, they have the 2FA code that they would need, and they could also replace the admin hash back to whatever it was before. So it kind of makes it a more stealthy attack if you chain the two together. So yeah, I don't think there was a particular bug in here that was interesting, but I think the way they were chained together for the attack was pretty cool, making it more stealthy.
Yeah, the chain is fun.
Yeah. So yeah, just a really cool attack overall. And it's a quick read. There's a bit you can skip through there, but yeah, it was well written too. So just wanted to call that out.
The HackerOne report is a bit more concise, but yeah, it's a good blog post.
Yeah. Up next, we have a Quarks Lab blog post on RFID and monotonic counter tearing. This is an issue that I don't think we've ever really touched on before. This is kind of a unique issue in that respect.
It's a unique issue. They did a great job explaining it because it's not something I was really familiar with I know you're a little bit more into the hardware stuff, but even you haven't really done much with the RFID.
No, RFID is not really in anything that I've looked at. It's kind of been like out of scope of what I'm interested in.
Yeah, it's one of those areas that like there are definitely people who are interested in do that research, but like you don't necessarily follow into it if you're just looking at hardware. Either way, so talking about this, monotonic counters, the counter only goes in one direction, mono. So in this case, they have these counters on board that are only supposed to go up. Pairing, if you're not familiar with the concept, for RFIDs, low power, or they don't actually have power themselves. Instead, the reading device will power the chip. So tearing or a tearing event is when you move the chip away from its power source. So you can kind of imagine the case where you've got a write going on and you move the card away from the power source, that write gets interrupted. That's where the anti-tearing comes in. The idea being that you can't like tear the write and get the counter to go back down or reset it to 0 or something. So the attack that they're covering in this post ends up being basically about doing that. Taking this monotonic counter that should only go up, can only be incremented, and resetting it to 0. Which I thought was a cool attack. This is actually their third blog post looking at different issues with tearing. And different attacks that can be done there. So all the links are actually in the bottom of this post, so you'll be able to check those out. They do cover a lot more detail in some of their past posts. Oh, and one other concept that kind of matters to this attack is the idea of a weakly programmed bit. So this can happen with with the tearing. If you kind of interrupt that write, you can end up having, and it seems it's a little bit more complicated than just like you tear during that particular bit's write or something. But the idea of it being that one of the bits, when it's being erased and then rewritten, so all of the writes will basically 0 or all 1 the bit, and then actually replace it with the value or flip all the bits necessary. So what can end up happening is you get this weakly programmed bit that sometimes when it's being read will be read as a 1, and sometimes when it's being read will be read as a 0. Usually, they're powering the bit or however they're doing it. You want to get it above a certain threshold. So if it's right in the middle there, it can be read as either way. Just kind of like a little bit of non-determinism. So the attack they end up having, like I said, was able to reset the counter to 0. And the way they did that was taking advantage of one of these weakly programmed bits, or a bit that could be weakly programmed. I guess I should also mention the write process. So they have this anti-tearing strategy, so you shouldn't be able to corrupt it. That process is every counter is backed by 2 memory slots that will be well, they won't both be written at once. But what it will do is that when you write to it, you'll have these 2 memory slots. Every memory slot also has a validity flag next to it, which just has a static value that gets written or unwritten and rewritten every time of 0x BD. So when you go to out of chat, IABR, RFID glitching, I mean, kind of glitching. Oh no, when I think about glitching, I was going to say I think of like power glitching, but I guess tearing could be power glitching.
Yeah, I would think it'd fall under that classification.
I guess it could. I was going to say I don't really think of it as glitching, but no, I guess you're right. Anyway, so the way they would do the anti-tearing is they would check that validity flag. So they would, first of all, just to read the counter, they would look at both counter values, make sure they both are, find one that has a valid flag. If they both have a valid flag, then it would take whichever one is higher. And then when writing to it, or incrementing it, they would read the value, of course, and then whichever memory slot they got back, they would write to the other one. So if this write ends up being corrupted, gets torn, the old value will still be known, and it still can't be decremented. So their attack, though, what they kind of targeted was they would find one of those weekly program bits where they can just kind of keep trying to read it, and notice the difference kind of happening. They would set one of the counters to just a power of 2, where the only bit set was this weekly programmable bit. So that counter slot would just, all zeros except for 1 bit. And so occasionally that might be read, and it will be read as a 0 instead of just that 1 bit being set. So if they were to tear during the setting of the other memory slot, tearing early so that they end up having that validity flag not be triggered, then when it goes to read it'll basically fall back on using the potentially zeroed flag. So trying that a few times, they can basically get it to reset to 0. I thought it was a cool attack. They do a much better job of explaining it in the post, and they have a lot more background in their earlier posts. So if you're like me and don't really know a ton about this, the earlier posts were definitely a lot of help. But I thought it was a really cool attack.
Yeah, Quarks Lab in general just does a really good job with these kinds of posts. And they're always interesting in the way that, like, a lot of the posts I see from there are things that I just never really see talked about elsewhere. Like I said, this is an attack that I haven't even... Like, we've covered some white papers, I think, that touch on RFID, and I don't think this attack was mentioned in them. It's just something that you don't really think about, and it's unique to how RFID is done. So, yeah, I mean, it's a cool attack. It is a little bit over my head, because it's not really in my area, but I think it is a cool write-up. And it's made as accessible to me as I think it could be, I guess. So
thank you, K9, for the bits.
Oh, thank you. Awesome. 69 bits. Nice. All right. So with that said, we'll move into our last topic, our last exploit topic of the podcast, which is from ZDI. This is a Wormable bug, although I will have a question about that later, in the Windows Internet Information Services, or IIS. The bug is kind of interesting. The post is not that great, but again, I will get into that in a little bit. This is a service that's typically used on Windows servers for things like hosting HTML, ASP, PHP, whatever. And Windows has their HTTP stack implemented as a kernel mode driver, which is probably not the greatest place to have that. But it's Windows, and it probably harkens back to legacy and wanting the best performance possible, not wanting to deal with context switches and whatnot. But if there's something you shouldn't have in kernel, it's probably something like this. So, yeah. The post starts out giving some background on HTTP headers and how they're structured. I'm mostly going to skip that because that's relatively boring and well-known. The header that...
yeah, I mean, if you're reading this, like, as an outsider, you probably already know a bit about how HTTP works. It almost feels like this is copy and paste. Like, they are providing this to their clients. This isn't necessarily for vulnerability research. Well, the post is for vulnerability research to consume. But clearly some of these things are written with the idea of, like, they're passing it to clients who maybe need all the background.
Yeah. So the header that contains the vulnerability and when it gets parsed is the accept encoding header for advertising the compression algorithm you want from the server. And then it'll respond with the content encoding header. So for example, you can use like gzip encoding or identity. You can also set a coding and pass a weight parameter. Well, with those coding types, you can either provide valid and recognized coding, like gzip, a validly formatted but not recognized one, like I think AAAA is one they give an example of, just anything that would be a valid string but just isn't recognized. Or you could pass a completely invalid one by using a semicolon or something inside of the coding name. The problem comes into play when they go to parse the content coding. And the fact that they keep a local doubly linked list to keep track of the nodes. And when it finishes building up that list, it gets copied into a request structure in the heap, but that local list never gets nulled out. So if you can trigger an error path by abusing like an invalid coding, for example, I believe, if you can trigger an error path that'll free the entries of the local list in the next request, it'll free the pointers from underneath that request object and cause UAF. Now, I kind of got that explanation from talking to some others and looking at some proof of concepts, because the ZDI post here was extremely confusing to follow. they have like 4 paragraphs that talk about how the doubly linked list is managed and whatnot. And maybe if you're familiar with the HTTP driver in Windows, it makes sense to you. But when I was trying to model the state in my head when I was reading this post, I was going crazy. So it's, the ZDI, there might be some better resources out there if you want to get a full picture of what the bug is. But yeah, it is a very cool bug, but it is a complex bug. So I can kind of understand why it was tough to explain. And if what you said is true, where it might be something for a client who would recognize their own code better, it kind of makes sense the way it's written.
Not so much as a client in that sense. Because they do mention at the top that this is part of a report, not the entire report. This is an excerpt from a Trend Micro Vulnerability Research Service vulnerability report. So that's what I meant by for a client like of Trend Micro providing. And yeah, ITCN out of chat just provided the proof of concept.
Yeah, the overclock talk has a good description of the bug.
Yes, and a very concise description of the bug. Yeah, right here, the bug itself happens, basically explaining where the bug happens. The only thing is, like, I'm sure this can be exploited, but I'd want to, I don't know. I mean, I feel like maybe I'm being too skeptical. Because, I mean, there's been all the claims about being wormable. I've seen a ton of posts kind of touching on that, and just, at least the example doesn't, but I suppose when they found it, they probably could have taken it off to code execution.
Yeah, so all the POCs that are out there, as well as ZDI posts, they kind of stop at triggering a kernel bug check, which I guess is kind of reasonable. You don't want to be putting weaponized bugs out there if it is a wormable exploit, so I can kind of understand that angle.
That's where I feel like I'm just being overly
overly cynical.
Yeah, I mean, I'm sure it's exploitable. I mean, this is basically, it's a perfect setup. You've got the dangling pointers in requests there. I'm sure it's exploitable. So I probably shouldn't have even mentioned any concern there on calling it wormable. It's just, yeah, I don't know.
So I did kind of want to talk about the wormable term usage, mainly just because it's funny that the ZDI post has that in the title. They want to get the attention of having wormable in the title, but they never mention it again. They don't talk about like how it could be wormed or whatever, which again I can kind of see because you don't want to empower skids, but it's just it was just a bit odd to me. But
yeah, I mean, I think it was in the oh no, I've definitely seen other mentions of it. I don't know exactly where the source was, if it might have even been out of like Patch Tuesday or something, while the doing the analysis there. Either way, I mean, it is likely wormable, so there's no reason really for me to doubt that.
Yeah, so it did come out of Patch Tuesday. I was going to touch on that a little bit. The bug was found internally, which is good. It wasn't found being used in the wild or anything. It was found by MXMS and Fuzzy HD1. MXMS is somebody I talked to a little bit in IRC, so it was cool to be able. I was actually able to talk to him a little bit about it, and I sent him the ZDI post, and he was saying, like, the way I read the ZDI post and the way it was formatted, it almost seemed to me like it was a brain dump. Like, if you found an issue, like, let's say you fuzzed. I think this issue was found through fuzzing. If you fuzzed and found a report, right, and you were trying to do some root cause analysis, this is the way I would write if I was trying to do a brain dump and just try to figure out what was going on. And I kind of said that when I sent over the link to the ZDI post, and MXMS was like, yeah, that's exactly what it was like when I first found it. Like, it was hard to work through the state. The only, like, with the ZDI post, I think what would have made it like 100 times better was if they had a diagram. Just a diagram showing the state of what was happening with how the linked list was being managed and how that tied into the UAF. But yeah, where it was just the paragraphs, it's tough. So, but yeah, like, this is a pretty cool bug, and once again, it's good that it was found internally. And I just wanted to call that out before we move into our shoutouts. So yeah, we will move into our shoutouts now. Z, I'll let you take it away, because we got a Project Zero one, which I wanted to get to read, but I just didn't have enough time on the weekend.
Yeah,
I don't know.
it's, well, fuzzing iOS code on macOS at native speed.
Yeah, I wasn't sure how much you read into it.
I've read over it. Like, I've read parts of it. I haven't gone through the entire thing. It's not that long. I mean, it's got a good scroll to it. But there's, the code segment and stuff. That said, seen some of the discussion around, so I at least want to call it out for you guys to check out. Like, it's basically, getting iOS code to run on macOS. I mean, it's pretty much what it says, getting to that point to do native speed fuzzing. The other shout out that I've got is a Keynote. Now, this is older. Weird Machines, Exploitability, Provable Non-Exploitability. From Thomas Dullien. I'm not sure if I'm saying that correctly. I've talked, especially actually because of the recent post about exploit dev, about like the concept of weird machines as being kind of an important concept to understand and grasp, and kind of one of the tougher things to grasp. And this Keynote, I think he also wrote the paper by pretty much the same name. I've read the paper, but the Keynote here, 40 minutes long, so it's not like a normal like conference paper type presentation. I thought just did a really good job at explaining it. At first it's really dry, but towards the middle when he starts talking about, what is exploitation and doing the definitions there, like it had one of the most concise definitions I think I've ever really heard. So I wanted to shout this out, even though it is several years old at this point.
Yeah, it had a really good diagram when they were trying to explain like how weird machines worked. I thought that diagram was a really solid way of demonstrating what was going on. I didn't watch the full talk. I just watched like a few minutes of it that you linked to that were really interesting. Middle. Yeah, but yeah, I mean the slides look good from what I was looking at, and obviously it's coming out of Project Zero. At this point, pretty much anything that's coming into Project Zero, you can expect to be good. So
yeah, I don't think I'm not sure if he's still at Project Zero. I feel like he left a little bit after this, actually, but
yeah, there has been a bit of movement in Project Zero lately. But I mean, anything, even like in the past, like anything that's really come out of them in the last like 5 years or whatever. I mean, they were just established in like 2012 or something, weren't they, or 2014? But yeah, like all through, they've been really solid with what they put out. So
yeah, so I wanted to call this out, like I said, especially in conjunction with the series about going from like CTF style binaries to more real world exploit dev. This is kind of the key concept that I think need to understand to start approaching modern exploits.
Yeah.
Whether or not you get it at all, he goes into like the formal explanations, everything. Whether or not you get it there, just understanding this concept. Don't get the idea that you need to watch this and just get everything, because he goes into a lot more of the formal logic also.
Yeah, it's the end of chat also calls out. Yeah, he went on to start his own company. Okay, cool. So that clarifies that a little bit with what you were bringing up. We do have another shout out as well, which is a browser fuzzing post by Mozilla. It's not super novel. If you've already looked into the fuzzing space and browsers, like looked at conference talks or just played around with it, there's nothing super new there. But it does give a nice overview of how browser fuzzing is set up and the fuzzing pipeline, at least when it comes to Firefox. Talking about like what kinds of sanitizers and debug builds they use for building the fuzz, some of the automated triaging they do with Fuzz Manager, as well as their own tool that they use, which is called Bugmon, which I don't think I've really seen before. I did a little bit of looking into it when I saw this post, but yeah, just a really solid overview of like how a fuzzing pipeline works in a like modern monolithic target.
And
so it just provides some insights there.
On more of a development side too, rather than just security issue. Well, I mean, it is for security issues, but
it's like an insider perspective.
Yeah, I thought it was really cool actually seeing this detail out of Mozilla, just seeing kind of what they're doing on that and their whole pipeline.
Yeah, it's a really good post, even though it doesn't have anything like earth-shattering in it or whatever. It's just a really good overview. But yeah, with that said, that's all of our topics for this week. Thank you to everyone who tuned in. VODs will be up on Twitch, Spotify, YouTube, and other platforms on Anchor 24 hours after the podcast. Again, this is the last episode before the break. That doesn't mean Day Zero will be going inactive or anything. It's just the podcast will be on break. We'll still be in Discord and potentially doing streams and other video releases, so keep an eye out for that. I'll also plug once more that our mini-series ongoing from CTF to real-world vuln research and exploitation is out and might be of interest to some of you out there. I'm also going to be putting out that VOD of the stream Z and I did where we looked at the new IDA free release, which includes their cloud decompiler. Again, we didn't really cover the IDA free release on the podcast, but we took a look at it in the stream, and you can check out that video to see our thoughts on it. Bit of a TLDR. They were positive. Cloud decompiler seems to be pretty good, and it's awesome that there's a free option now, other than just Ghidra for decompilation. I should say a decompilation that doesn't suck.
One of the few times that we have been talking positively about IDA.
Yeah, it was a nice change of pace to be able to shower some praise on Hexrays a little bit. But yeah, that said, we won't see you next week on Monday, but we will see you when we return in September. Just keep an eye out on Twitter and our Discord for announcements of any other content we might drop or streams that we might do. And we will see you all back on the podcast on September 6th.